All right, so now we've got, you know, the full-fledged problem. It's got everything, right? Okay, so water flows at pressure of, it's a 10 centimeter pipe at ground level, goes up to 3.5 meters high, and it narrows, right? So we've got it narrows, right? So here it's 6 centimeter diameter. So radius here is 0.03 meters. The radius here is equal to 0.05 meters, right? So 10 centimeter diameter, right? This velocity 1 is 2 meters per second. These are almost easier, right? This pressure 1 is equal to 1.15 times 10 to the 5th pascals. And then this elevation here is, this change in elevation is 3.5 meters. I think there's only going to be one zero term here, right? Then we want to know what's the pressure here. What's pressure 2? Okay, the first thing we got to do is we got to figure out V2, right? So let's go A1 V1 is A2 V2. Okay, so pi times 0.05 squared times 2 equals pi times 0.03 squared times V2. All right, we got to solve it. We're solving. All right, notice that the pi's go the way of the bison here, so I'm going to go 0.05 squared times 2 divided by 0.03 squared. Ultimately, it's just the ratio of the squares, right? And I get that V2 is equal to 5 point, a lot of fives, it's 5 repeating, 5 meters per second. All right. So now we're gonna Bernoulli this. Okay, so we got 1/2 rho 1 V1 squared plus rho, should I go for the Z? I believe so. Plus P1, right? Is equal to 1/2 rho. Oh, there's not a rho 1, right? It's just rho. Rho V2 squared plus rho G Z2 plus P2. All right. When I get a lot of writing on the screen, this pen slows down. Let's see. Where are our zeros? I think the only zero we've got is that Z1 is going to be 0, right? Where we start at the ground level. So that's a 0. So now I think we've got everything. We're going to go 1/2. It's water, so it's 1,000 times 2 squared, right? Plus 1.15 E5. That's this pressure 1, right? Is equal to 1/2 1,000 times 5.55 repeating squared. And don't round those things, like type a bunch of 5s or maybe use the number on your calculator, right? Plus, let's see, 1,000 times 9.81 times Z2 is the 3.5 meters elevation. It's almost like these are easier because there's like very few zeros here, right? And then plus pressure 2. Okay, so I'm going to start on this side. I'm going to go 0.5 times 1,000 times 2 squared plus 1.15 E5. Now I'm going to subtract this term, minus 0.5 times 1,000 times the number I just got, squared. Then I'm going to subtract this term, minus 1,000. So it's going to be less, this pressure will be less than this pressure because it's moving and because it's higher. Okay, so times 9.81 times 3.5. Enter. Hopefully I get the right answer. Oh wow, it's quite a lot. Okay, so pressure 2 is equal to 6.723 times 10 to the 4th pascals, which indeed is less than 1.15 times 10 to the fifth. And it's less because it's higher, right? So hydrostatic pressure contributed to it. It's also less because it's moving faster, okay? It's all Bernoulli. Bernoulli.